Hi, welcome back to the Cosmic Classroom. Let's talk now about Newton's second law of motion, or force equals mass times acceleration, or for short, F equals ma. So we say that the net force, and the real reason it says net is because, well, of course, if you have one force pushing in one direction, another force pushing in another direction, there may be no net force. So if there is a net force, if there is a total force in one direction, that force will cause an object of mass m to be accelerated. It will change, therefore, the motion of that object. Okay? So remember that acceleration is the rate of change in motion. So it's not that an object will start traveling at constant velocity, but an object will really speed up or slow down if a force is applied to it. So for example, if a small force is applied at a small mass, you may create a small acceleration, right? If you increase the mass, you need a bigger force to achieve the same acceleration. Or with the same force, you get a smaller acceleration. So this boy is able to change the motion of this cart from rest to some velocity because he's applying a force on it. All right. If the car becomes bigger, now the boy would need a much bigger force to create the same change in motion, the same acceleration. The force would need to be much higher. Right. So chances are that the force that this boy is applying is so small that the acceleration is going to be very, very tiny. Right? So that's it for Newton's second law. Force creates a change in motion in an object. The bigger the mass, the bigger the force you need to change the motion of an object. And keep in mind the difference between velocity and acceleration. I hope it helps.